Welcome to Premath. In this video tutorial, we have got this semicircle and we got this right triangle ABD such that the diameter of this semicircle EF is collinear with one side of this right triangle, and moreover this point D is a point of tangency, as you can see in this figure, and we are going to calculate the value of this x. And here's the information that is given to us. AE equals to 1 over here, as you can see this 1, and EB this is x value that we are going to calculate, and then EF is equal to 2 is our diameter, and finally EC and CF, which is equal to 1, is our radius, as you can see over here. So let's go ahead and get started with the solution, and here's the very first step. Let's connect these points C and D, and this C is our center and D is a point of tangency. Let's go ahead and connect these 2 points, and here's our much nicer looking diagram, and you can see that this CD is our radius and this has a length 1. And here's our tangent to a circle theorem. The angle between a tangent and a radius is always 90 degrees. That means they are perpendicular. So thus this radius CD and this tangent line are perpendicular to each other. And here is our next step. Let's focus on this triangle CBD over here, and we can see that this angle is 90 degrees. And I'm going to call this angle alpha. Then this angle is going to become 90 minus alpha. And here I just copy down this thing, 90 minus alpha, then plus alpha, plus this 90 degrees triangle. And we can see this positive alpha, negative alpha cancels out. So that is equal to 180 degrees indeed. Now let's focus on this triangle CDA, and we can see that this angle D is a right angle, which is 90 degrees over here, and this angle is alpha. Then indeed that this angle is going to become 90 minus alpha. And here I have copied down these 3 angles of this triangle CDA, 90 minus alpha, plus alpha, and plus 90 degrees. And we can see this negative alpha and positive alpha cancels out. So we end up with 180 degrees. So that means that the sum of these angles is indeed 180 degrees. So thus we conclude that these triangles CBD and triangle CDA are similar triangles according to angle theorem. And by the way, here's the angle theorem. If in 2 triangles corresponding angles are equal, then the triangles are said to be similar. And now since these 2 triangles are similar, so we can use proportions. So we are going to use these ratios of small leg and the long leg, and that is going to become CD divided by CA equal to CB divided by CD. All right. And now we are going to find the value of this CB, which is right here. This CB, we want to find out how much this one. We know that this radius is 1 and this length is x, isn't it? So this side BC is going to become 1 minus x. That means this CB rather is going to be 1 minus x. Now let's go ahead and fill in the blanks over here. CD in our case is the radius is 1 divided by CA is in our case is 2. As you can see, CA is, this is radius is 1 and then this plus 1 makes 2. So this CA total length is going to be 2 equal to CB, we just figured out 1 minus x divided by CD is 1 again. So let's go ahead and cross multiply, crisscross. So we are going to get 1 times 1 is 1 equal to 2 times 1 minus x. And let's go ahead and simplify. When we distribute this thing, that's going to give us 2 minus 2x. Now let's move this negative 2x on the left hand side and move this 1 on the right hand side. So we are going to get 2x equal to 2 minus 1, or simply 2x equal to 1. Let's divide both sides by 2 to isolate x. So x value turns out to be simply 1 over 2. So thus our x value turns out to be 1 over 2. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.